Hello everyone, this is Mrs. Sargent and this is lesson 5.4, converting between all units. So we started this unit talking about what a mole is, and then we converted between particles and moles, and then we calculated molar mass and converted between mass and mass and moles, and today we're going to combine it all together. So mass to particles, particles to mass, and everything in between. So on your mole map, we're going to start looking at side 2. And on the mole map, there are 2 different pathways. So one pathway is starting down here at the bottom left at mass given, following the arrow to moles. We could convert mass to moles like we did in 5.3. Or we can also continue on to particles. And the second pathway that we could take is starting at particles and converting to moles. We did that in lesson 5.2. But then we can also take the moles and convert to mass. So you are not going to go top to top. It's going to be top to bottom or bottom to top on here. So when you're using side 2 of the mole map, there's more steps involved. So I suggest that you find where you start. So look at the units that you're given. Is it grams for mass? Is it moles? Is it atoms? Is it molecules? Formula units? Some type of particle. So figure out where you're starting. You can start up here in the top left. You can start here on the bottom left, or you can start here in the middle at the moles. So those are your 3 starting places. You're never going to start over here on the right. So pick which one of these matches the unit on the number that you're given, and then what it is asking you to find for your wanted. Figure out if you are going to end top right, bottom right, or you could also end here at the moles too. So that's number 2, find where you want to be, and then you're going to follow the arrows and use the proper conversion factors that are listed along the arrows to do your conversions. So all conversions between units must go through the moles. Moles is the only comparable unit between different substances. Because we talked about that different substances have different molar mass, so we can't compare masses, but we can compare moles, because with moles we know that every mole has the same number of particles. So as a reminder, 1 mole is equal to your molar mass in grams. That's why we can use our molar mass as a conversion factor. And then also 1 mole is equal to 6.02 times 10 to the 23rd particles. So let's look at some examples. This first problem says, what is the mass of 4.59 times 10 to the 22nd atoms of 10? So we are given atoms. We're going to write down that number and unit. And that is given to us. And we want to find our mass. So I'm going to look back at the mole map. We are given atoms, and we want to find mass. So I'm going to start up here at the top left and follow the arrow all the way down here to mass wanted. So the first conversion factor is 1 mole over 6.02 times 10 to the 23rd particles. And in this case, The particles that we are working with are atoms of 10. Then going from moles to mass, we have the molar mass over 1 mole wanted. And for 10, since this is just a single element, we can look at the periodic table for the average atomic mass, and this is our molar mass of 10. So the conversion factor says molar mass over 1 mole wanted, so we're putting the 118.71 grams of 10 over 1 mole of 10, and then we can cancel out our atoms of 10 and our moles of 10, and we're left with grams of 10, which is what we want. So we're going to take 4.59 times 10 to the 22nd, multiply by 118.71, and then divide by 6.02 times 10 to the 23rd, and this is going to give us 9.05 grams of 10 for our answer. In this next question, it says to calculate the number of molecules if the mass of the sample is 45.12 grams. So we are given grams and we want molecules. So I'm going to look back at the mole map. On this problem, we are given grams and we want molecules. So I'm going to start down here at mass given, since I have G for grams on my number, and I want to go to molecules. So I'm going to end up here on the top right. First conversion factor is 1 mole over the molar mass. So like we talked about in 4.53, anytime you have mass or you are asked to find mass, you have to calculate the molar mass. So when we do that, we're going to take our NH3, and remember you got to split it into the elements that compose that compound, and we need to look up on the periodic table what the average atomic mass is. So for nitrogen, it's 14.01. For hydrogen, it's 1.008. Then we need to multiply by the number of atoms in the formula. So we have 1 nitrogen and 3 hydrogen. So this is going to be 14.01. And this is going to be 3.024, I believe. Yes. And then we add the mass of nitrogen and hydrogen together, and we get a total of 17.034 grams per mole. So we already have the per mole part on the top. We're putting 17.034 grams on the bottom. So that, then we can cancel out our grams, and so we're at moles. We want to go to molecules, so we're going to look at our mole map, going from moles to molecules. We need 6.02 times 10 to the 23rd particles over 1 mole. So 6.02 times 10 to the 23rd. Our particles in this case are molecules of NH3. And that over 1 mole of NH3. Now we can cancel out moles. And so we need to take 45.12, multiply by 6.02 times 10 to the 23rd, and then divide by 17.034. We have 4 sig figs to start with. So we need 4 in our final answer. 1.595 times 10 to the 24th molecules of NH3. There is our answer for that one. Okay, so that kind of showed you an example of each of the different pathways that we talked about on the mole map. And then one other example that I wanted to take a look at with you, this question says how many atoms of sulfur are in 35.0 grams of aluminum sulfate. So we're given grams of aluminum sulfate and we want to find atoms of sulfur. So this is similar to the problems that we did in 5.2, where we were converting to particles and we had a compound, but we wanted a specific atom. So that's what this one has, that one extra step past the mole map. So remember, anytime you have mass and you are asked to find mass, you need your molar mass of that compound. So we need to look up our average atomic masses. Aluminum is 26.98. Sulfur is 32.06. Oxygen is 16. Multiply by the number of atoms in the formula. So we have 2 atoms of sulfur. Remember that this 3 distributes in. So we have 3 atoms of sulfur, and then 3 times 4. We have 12 atoms of oxygen. So this is going to give us a mass of 53.96 for the aluminum, 96.18 for sulfur, and 192 for oxygen. Then we need to add those together. And I found 342.14 grams per mole for aluminum sulfate. So we have grams on the top. We're going to need to put the grams on the bottom. 342.14 grams of aluminum sulfate. And I am still following the mole map. So let me take a look back at that. We are given mass and we want to find a specific atom. So we're going to go from mass to, instead of molecules, we're going to go to formula units and then add that one additional step on. So we have 1 mole over the molar mass. So I need to put the 1 mole on the top here. And so now, before we can go to atoms of sulfur, we need to go to the type of particle, which is formula units. So that is 6.02 times 10 to the 23rd formula units over 1 mole. 6.02 times 10 to the 23rd formula units of aluminum sulfate per 1 mole of aluminum sulfate. And then, so now we're at formula units. In 1 formula unit, how many atoms of sulfur do we have? We have 3 atoms of sulfur to every 1 formula unit of our aluminum sulfate. So formula units cancel. So we need to take 35.0 times 6.02 times 10 to the 23rd times 3. And then divide by 342.14. We have 3 sig figs to start with, so we need 3 sig figs in our answer. 1.85 times 10 to the 23rd atoms of sulfur. So this last step is that one additional step past your mole map. So hopefully that gives you some good examples to work with. You do have practice on the following page. And remember that you can start at any one of these 3 points and you can end either here, here, or here. And so your practice is combined between all of that. If you have any questions, please don't hesitate to let me know. I'm more than happy to help. I hope that you have a great day. Thank you.